So this is science communication and science literacy, and I wanted to just talk a little bit about some of the lessons that we've learned from our Schaal colloquium on the science of science communication. So again, this was through the National Academy of Sciences, so we're really focusing on the basic science of how we can communicate better. I wanted to remind you from my last presentation on the flow of influence pyramid, and there was this big red line here where basically the NAS and many of us stop because down here is the public, and it's hard for us to reach the public. It's hard to us to reach the public because we don't have expertise, we don't have resources, but I think we've heard about it repeatedly in this meeting. This is where the real action is, and there's a lot of desire for us to go down into that, not down into that level, that sounds terrible, for us to attempt to reach up to the public in a really appropriately respectful and influential way. So a lot of the things that I showed previously, I had two conclusions. One, public opinion can change the public trust in scientists. This gives us hope that we can actually go and interact with the public, and we know that there's a lot of desire to do that. So this is our colloquium that we had, and the questions that we really address in it is how can we communicate better? And goal of communication, we wanted to educate and inform the public, and we also like to change people's minds. We would like people to really understand that there is climate change out there, and we need to, as a public, as citizens of the U.S., we need to get our government to do something about it. We also know that we're often ineffective and that we can often fail. And the usual strategy that we have is we know our science, we know we're right. I think all of us could go online and come up with a whole series of graphs and information that would show that the climate is changing. We're correct, but we can't get people to believe us. We can't get people to listen to us. So what we do is we talk louder and longer and with more detail, and we become less and less effective. So the idea is, how can we change that? And it's not all of us. I mean, there are some brilliant communicators, and we certainly heard some of them at our symposium. So the challenge really is, how can we improve? How can we do a better job of communicating with the public? And then the other thing, this is really important, I think, for all of us that are scientists, is how can we be both effective, that means do a really good job, and actually get people to listen to us, and also be true to the science. I think one of the things that we worry about when we start talking about bringing in theater experts and communication experts is that we become too slick, too much like a showman. We're using too many tricks, and we're no longer true to the science. I mean, I know that that's really taking that argument and making it very polar, but there is certainly that concern in the community. So we want to be true to our science, we want to give correct information, appropriate information, and we want to do it effectively. So one of the ways to figure this out is how can we be more effective, is to figure out why we aren't effective. So how do we fail? And here I need to acknowledge Arthur Lupia from the University of Michigan. He gave this terrific talk on this topic at our symposium, and it's available online. If you Google, if you look at Schaal colloquia, the science of science communication, the whole thing is a webcast, and you can access this. And if you have 25 minutes, this is the talk to listen to, because he did a really great job. And the idea, a couple of the ideas that I'm going to present are his. They're not my intellectual property, they're his. So why do we fail? Well, we fail because we don't acknowledge biological factors. And the biological factors are the biological limitations of our mind, of our neurobiology. And so that puts constraints. They are physically what we are able to do, what we're able to understand, how we're able to be persuaded. Another thing that we don't understand very well is how people make decisions. How do you decide whether or not you can believe in climate change? And then we also don't understand how to effectively persuade. And so this is where we think there's this emerging area of the science of science communication, is that we think that we can apply basic science, we can go into social sciences, into neurobiology, into psychology, to help us understand these kinds of questions, so that we can in fact use this knowledge to more effectively communicate. And that's what we're trying to do in these Schaal colloquia. So what are some of the sciences of science communication? There's neurobiology, basically memory, the neurobiology of memory. What is memory? What are the constraints on memory? And there's also biological constraints on attention. And I talked about this before. Biological limitations on memory and attention. We have a working memory, and it's not infinite. It's in relatively short supply. It's limited supply. And there's this rule of 7. If you have trouble with your memory, you can only remember 5 things. If you are really good, you can remember 9 things. They could be numbers or colors, but there's just simply a limit to what we can store in our brain short term. And that's a limitation, no matter how great your argument is as a scientist, no matter how wonderful my facts are as a rice genomicist, you're not going to remember more than those limited number of things, because it's just physically based on your brain. You can't do much more. And so that's something we have to remember when we're talking to people. You can't expect, even though I expect my students to do it, which is another whole topic, but people to remember 25 things, and then all of a sudden you bring all of that together. You can't go and say, well, remember what I told you a little bit ago, because people don't remember that. It's hard. Then the other thing is, and I talked about this on Sunday, is the competition for attention. So all of you have lots of things that is competing for your attention. So I'm going like this, I'm trying to get you to pay attention to me. But you're also thinking about that pyramid and why was it turquoise, and then you're thinking about we're getting hungry and what's for lunch, and these are the normal sorts of things. And that's based on your biology, and it's based on just the way we are as people. It would be great if we could be perfect and not have that problem, but we're all human. Yeah.
Barbara, how do these fantastic musicians here play whole concertos from memory?
Well, so you have to read Daniel Kahneman's book, Thinking Fast and Slow, and he talks about how people are able to do that. Oh, there it is. Yeah, it's a terrific book. There are also and the other thing you should be raising your hand about. Oh, wait a minute. There's people that can memorize a phone book. How do they do that? There's a book written on memory, and it used to be like with the Greeks and Romans, that was something that people prided themselves on, was being able to memorize huge texts or lots and lots of information. And it turns out there's ways of doing that, and there've been a couple, and I can't remember, interestingly, I can't remember the name of the book or the author. Do you know it?
John Lehrer.
Yes, yeah.
There's no conflict here.
Right.
He's talking about long-term memory, you're talking about short-term
Exactly.
memory.
Yeah.
Yeah, but even just I could if you do these tricks, you can actually memorize much more than nine digits, for example. And one of the tricks is, let's say you have a bunch of things to memorize, such as a shopping list, mustard and salmon and eggs and oranges, and you might have 10 things. Normally we can't keep that in our short-term memory. But what you can do is you have these, and I forget again what it's called, but it's basically a pathway, and you take one of these objects, like maybe the one that I use is I'm walking up my driveway, and where the sidewalk is, I place the salmon, and then where the gate is, I place the eggs, and then I put the oranges here, and all of a sudden you can go through you can take this path, and you can literally pick up all of these different things. So there are tricks to really expanding that, going beyond that rule of 7. It's a cute book.
Actually, I'm sure you don't want to wander too far off the path from the main point, but this may be relevant because I think you're telling us this because you're telling us if we're giving a talk or presentation, how do we optimize what we're doing? So that's wonderful. And I wonder whether this may be useful as well. People in theatre, the performing arts are able to do remarkable things with short-term memory because, analogously to what you're saying, they form an emotional map, and that actually helps navigate. Yeah. And one could imagine actually constructing an emotional map in one's presentation that helps distribute the facts in a way that make them more easily memorable.
That's exactly right, and I'm not going to go into that, but in fact, one of the major ways to communicate with people is to do it emotionally. That's how you make those connections, and that emotional map will absolutely just take you through something. Yeah. This is not. I study rice genomics, evolutionary genomics of rice. The things that you eat. So this is not my area of expertise at all. So I'm just relating what I have learned, which is at a very superficial level. Also, social sciences have a lot to add. How we make decisions, how we are influenced, and perception of risk. And this is just an example. So which is more scary? This is water, but it's also dihydrogen monoxide. And so these kinds of things, these scary names, and those are all things that you could study in terms of social sciences. And there are some really interesting studies that can be done. This is I think it's Daniel Kahan, and it's from some of the other things that I talked about. The nature, it's in Nature Climate Change, and it's basically looking at how people perceive climate change. And this is actually testing what causes influences. So there's a science comprehension thesis, and that is that the more you know about climate change, the more you will believe in climate change. So if we educate people more and more and more, they're going to believe us more and more. And that should be a graph like this. So when they actually go out and do this, they come up with exactly the opposite, that there's science literacy, and the more you know, in some cases, the less you believe in climate change. And that's because of the social context of some of the arguments about climate change. So I don't put this up here to argue about these data, but just simply to show that there are social science ways of actually getting at some of these issues. And these are the sorts of things that we're going to try to explore in our in our symposium series. And then I talked about this just on, I already talked about this on Sunday about communicating with the public, where you have the TV show ER, and we talked about HPV and how that really increased the knowledge of the public by just the TV show talking about it, and by really enhancing people's understanding about the importance of vaccination for HPV. So this is, you can't read this, this is the test before ER episode on HPV. 19% of the people felt, 19% of the viewers had heard of HPV and knew that it was associated with cervical cancer. 1 week after ER, 60% of the people surveyed knew that HPV was associated with cervical cancer. And then 6 weeks after, it was still up to 38%. So these are the kinds of things that we've really tried to use in some of our programs. And the one that I talked about was a science and entertainment exchange, where we wanted to take advantage of the obvious ability that entertainment channels possess to transmit these kinds of messages. And so we've done it all the way from adding more science into things to providing better views of science. There's some movie, again, whose name I don't watch movies very much, but there's some movie that either has come out or is coming out, and the heroine was supposed to be a nurse. And through some of these interactions, the heroine now is, you will love this, a physicist. And the actress is the one that played the ballerina in that one movie. Natalie Portman, yes, thank you. So yeah, these are major influences, and that's one of the things that we're trying to do. And with that, I'm going to stop because I want to hear everybody else. So I'm going to close this up, and I think we can come up here.
Yep.